Hello everyone, I am Soumya from the Department of Artificial Intelligence and Data Science at SNS College of Engineering. In this session, we will explore the concept of functional independence, a foundational principle in object-oriented software engineering. Let's begin. Introduction to functional independence. Functional independence refers to designing the software modules that focus on a single function with minimal interaction with other modules. The core idea is simple. Each module should do one job and do it well. These principles makes our code more modular, reusable and maintainable. Why functional independence matters. Why this is important. When modules are functionally independent, our software becomes more modular and reusable. Debugging, testing and updates becomes easier. The risk of changes in one module affecting the other is reduced here. Overall, it leads to better maintainability and helps the development teams work more productively. Then, core elements of functional independence. There are two core elements behind functional independence. First one is cohesion. These makes how closely related the task in a module are. The higher the cohesion, the more focused the module is. Then coupling. These measures how much one module depends on another. Lower coupling is better because it makes the modules more independent. So too, achieve the functional independence, we should aim for high cohesion and low coupling. Then, characteristics of functionally independent modules. What does a functionally independent module looks like? It performs a specific task. It has a clearly defined interface. It communicates very little with other modules. It contains its own logic and data, meaning it's self-contained. These characteristics makes the module easier to test and change and reuse. Then real life example. A simple example is a calculator application. Each function like addition, subtraction, multiplication and division works independently. You can modify or test the multiplication function without affecting the others. This is a perfect demonstration of functional independence in design. Then a real life example of coupling. Let's take a bigger example, an e-commerce applications. It has the modules like a payment, inventory, order management, etc. Each of these performs a distinct function and communicates through defined interface. If the payment module needs an update, you can do it without affecting the inventory system. Um, then benefits of functional independence. Functionally independent modules bring many benefits, easier and faster testing and reusable across multiple projects and clearer and easier to understand the code, and it supports the parallel development by different team members and fewer integration issues during the development. All of this adds up to improve the productivity and software quality. Then, relationship with modular design. Functional independence is closely related to modular design. Each independent function becomes a module here. These modules can be developed, tested and deployed individually. These kind of structure supports agile and scalable software development practices. Then key takeaways. Let's summarize the key takeaways. We should always aim for high cohesion and low coupling. Functionally independent modules are easier to develop and maintain. They form the backbone of object-oriented and modular software systems. So, when designing any class or module, ask yourself, is it focused or it is independent or not? Then summary, to conclude, functional independence is a key to high quality software. It's achieved through good modular design. The golden rule here is do one thing and do it well independently. Always apply this when designing the classes, modules or even microservices. Thank you for watching.